In this video, I'll give a quick guide to a roadmap for learning programming using open source software. The programs GCompris, Laby, KTurtle, and Robocode are free to download and can run on a Raspberry Pi. I'll touch on some software concepts like variables, functions, and loops, and describe some games where you solve problems by writing programs. What is software? It's a set of instructions for a computer to do to solve a problem. The software takes some inputs, does some processing using the instructions of a programmer, and produces some outputs. I'll quickly go over some instructions now and come back to them later, so don't worry if it doesn't make sense right away. Those instructions will probably include conditional statements like if-then, or if-then-else decision blocks, where certain code is executed depending on inputs. Loops like while loops, do-while loops, and for loops, so the same code can be easily run many times. In calls to functions like print text to screen, some text, or load file from file system, file name, which transfers control to another segment of code to do something. A function can also be called a procedure. The terms are interchangeable. Take an example of a recipe where we bake cookies. Exactly how we make the cookies isn't important for now, just that if we follow the recipe, we can make a batch of a dozen cookies. In this way, we have a function bake batch of cookies, which has a step-by-step code for it. Some functions can have arguments passed to them. Bake batch of cookies might take an argument which is a variable that is passed to it by the code calling the function and change what it does. In this case, the argument could be add choc chips. Code inside the function could have a segment after the dough is mixed, but before it's put in the oven, if add choc chips, then put chips in mixture. There might also be another if statement later to increase the time the mixture is baking by a minute to account for there being a bit more in the oven. We also have a large oven which has space for 2 trays, so we can make a double batch and bake at the same time, being a little more efficient. We'll call this function bake double batch of cookies. But if we need to make more than a double batch, we need some more code. If we know the variable batches of cookies to make is set and passed to us, we can use the following code. While batches of cookies to make is greater than 1, bake batch of cookies, and then batches of cookies to make equals batches of cookies to make minus 1. This will loop around until batches of cookies to make is 0. That's an okay program and will get the job done. But we can be a bit more efficient by making double batches if we have to make more than one. So the code would look like, while batches of cookies to make is greater than 1, if batches of cookies to make is greater than 2, bake double batch of cookies. Batches of cookies to make equals batches of cookies to make minus 2, else bake batch of cookies. Batches of cookies to make equals batches of cookies to make minus 1. If you're still unsure, that's okay. It should make more sense when we go through and use some of the programs. GCompris is an educational program with many different activities. The main one we're interested in for this presentation is Programming Maze. In this activity, the user has to give Tux the penguin instructions to reach the fish by walking along blocks of ice and avoiding the ocean. The activity gets slightly harder when each level is complete. The first one, Tux just has to walk forward to get the fish. The next levels add some turns. Instructions include walk forward, turn left, turn right, and in later levels, calls to a function. As the program runs, the player is shown Tux moving along. If Tux would walk off the ice or doesn't finish in time, the player gets another chance to complete the level. Once a player finishes all the levels, they should be familiar with how functions work. The game is a little bit like programming in assembly language, where the computer is explicitly told what to do step by step by the programmer. The other programs use high-level languages like C or C++ or Java, and KTurtle uses a customized language similar to BASIC. Laby is a puzzle-oriented game where we have to write a program to give instructions to an ant to escape from a semi-randomly generated map. I think it does a great job of introducing a player to core programming concepts in a controlled environment without all the bells and whistles of a full integrated development environment. When the program starts, the player can choose what language the game is played in. On my computer, I can choose C, C++, Java, and Perl. I recommend C for the first time through. The game contains around a dozen levels, showing a 2D world with brick walls, spider webs, rocks, and a door to escape. The player has to get the ant to the door and open it. On the first level, this is simple and the player uses instructions like forward, left, right, and escape when they're in front of the door. On the second level, it gets a bit harder, as there's now a rock in the way, and the player has to tell the ant to take and drop the rock, which the ant can carry around. The later level introduces a while loop and gets the player to write a program for the ant to step forward while the space in front of the ant is empty. Another level introduces procedures, so the same code isn't written many times. The game then introduces spider webs. There are small and large ones. The ant will get stuck in the large ones, but can walk through the smaller ones. One level has two parts, left and right, and it's random whether the large spider web is on the left or the right. The smaller spider web is on the other. The player has to code the program to go to one web location and check if it's a large spider web and reroute if it is. Otherwise, it can just step through the smaller one. The player won't know until they hit execute to run the program which side has which web. The next level has two corridors again, where the player has to navigate webs first, and then a possible rock for the ant to move. Again, these are randomly placed when the player hits execute. There are also some more levels with long pathways, and another level is one where the player has to correctly go down one of 5 corridors with a smaller web to escape. There are also some levels I consider to be bonus levels, for players looking for more of a challenge. There's a link to me playing through most of the levels in Laby in the comments. After completing a playthrough of most levels of Laby, a person should be able to write and understand simple code. And I consider it a great stepping stone to more in-depth programming environments like KTurtle and Robocode. KTurtle is the next step I'd recommend, as it allows the user to interact with a much bigger environment and do more. Players control a turtle, and as it moves around, you can draw lines with a pen to create different pictures. There are several examples provided with the program, and it also allows people to download other code examples, like a program that uses recursion to draw a tree in a fractal pattern. There is documentation for a student to study and learn advanced commands that can be used, and it's intended to be learnt fairly easily. Robocode is a program which allows players to write code for virtual tanks, which can then be put into an arena with other tanks running the same or different code to fight each other. This application is developed in Java, and players also code their robots in Java. This will expose the user to advanced coding concepts like object-oriented coding. Users will also go through some documentation to learn which application programming interface calls they want to make to control their tank after they decide which strategy it will use to win. There are quite a few sample bots which can be modified. Some bots just sit there as a target to practice with, others drive around in circles and shoot, while some move backwards and forwards or travel around the outside of the map while firing. Where to next? I guess what you're looking to do next depends on what you want to do. Some of the main languages are Perl, Python, Java, C++, and for those working in depth with Linux, spending some time to learn bash scripting could be useful. The Raspberry Pi has several resources that will help people learn coding, and the Pis have hardware like a Sense Hat to allow people to write code and interact with the outside world. It also has an emulator, so you can write code to interact with a simulated Sense Hat. You can control things like the temperature sensor and push virtual buttons on it to test your code, and the emulator can illuminate virtual LEDs as output. There is also a virtual bookshelf on the Raspberry Pi operating system that has several books about coding, including some about coding games. You can also download some open source software to compile and make changes to it. If you wanted to develop an AI, there are games like Dream Chess and Empire, which can be downloaded to change how the computer player behaves. I hope this has been useful in giving a listenable overview to learning computer programming. If you have any feedback, please leave a comment, and if you found it useful, please share it with some friends.